Hello guys, welcome to this lesson about differentiation rules where I will be talking about the sum and difference rules. Okay, what do they entail? The sum rule is about a function expressed as a sum of functions. It says that if you have that situation, then the derivative of the function will be equal to the sum of the individual derivatives of the functions. And similarly, the difference rule says if a function is expressed as a difference of functions, then its derivative is equal to the difference in the derivatives of the functions. Okay, as you can see, there are two functions here that we're going to consider in our attempt to understand how to use these rules. Okay, and therefore, before that, there are some precautions that I want to make you aware of. If a function is given as vectors or in radical form or as a rational function in terms of a hyperbola, what do we need to do? There must be preparation before differentiation. Okay, you need to make sure, is my function prepared for differentiation? And I'll talk about that more as we go through the examples here. Okay, and in the book, where are we? Book, Inquiry Approach to Mathematics. We are on page 214 all the way to page 216. So if you have it already, you will be having solutions then for these two questions. Okay, and I encourage you, of course, to do the rest. Now, let's look at the question. Determine dy over dx. This is the notation for differentiation. It's one of the four notations that we have. As you will see in the book, I give the theory, of course, in terms of the notation that you need to be aware of. So what is the meaning of this notation? It says differentiate y with respect to x, because the usual way of expressing functions is a relationship between x and y, because in our Cartesian plane, we have the x-axis and the y-axis. Okay, so if what is given? If y is equal to 3x cubed plus 4x squared plus x minus 4. So we understand and we see that what we're given is a function containing four terms. And the sum rule says you are now seeing this as separate functions, and you're going to derive each function separately, and that will be at the end the sum of the derivatives, giving you the derivative of y itself. Okay, so we see four functions. So how many times must we differentiate y with respect to x? 4 times, because there are four functions. So let's start. We see a power function. It's a power function. This also is a constant function. Okay, so we're gonna work with it separately. The first question you ask yourself, is my function prepared for differentiation? Yes, that is fine, that is fine, that is fine. It is a constant function. Okay, so we are ready to differentiate. Bring in our notation dy over dx. Okay, and how do we do that? There's a power function, we drop the exponent, and the resulting function will be 1 less in degree than the original function. So it is a 3 times 3x to the power 3 minus 1, plus, you drop the exponent, 2 times 6x to the power 2 minus 1, plus, the exponent of x here is what? I hear a 1, that's good. So you drop the exponent, 1 times x and 1 minus 1. Minus what? We did this in the previous video. The derivative of a constant function is 0. Okay, and what does this become? Well, 3 times 3 is equal to 9, and then the resulting exponent there is 2, plus 2 times 6 is 12. The resulting exponent there is what? 1, plus x to the power of what here? 1 minus 1 is 0. So you're not going to leave your answer like this, especially with this guy right here. You understand that by exponential laws, if you have an exponent of 0, given that your base is not 0, then the resulting, or the result would be 1. So you continue and write this as 9x squared plus 12x plus 1. And that is the function that expresses to us the derivative of this function y with respect to x. Good, guys, we are done with number 1. Look at number 2. What are we given? We are given y in terms of x, of course. How many functions do we see? 1, 2, 3. So we are given 3 functions here. And remember, it's sum and difference rules that, is applied and worked with simultaneously. So what is that question that we ask ourselves? Is the function ready to be differentiated? Look at the first function. No, this is a radical. We need to take care of it. Convert the radical into an exponential form. Okay? This one, no, because it's in rational form. The variable, we need to take it up so that it's a power function. Okay? This one is 1 over 2 pi, which makes it a what? A constant function. It's just a number independent of x, so therefore it's a constant function. So we don't bring in our notation yet because we are at the preparation stage before differentiation. Okay, so we are still dealing with a function and we are preparing it now. So how do we write the first function, in a way that will allow us to differentiate? The square root, the equivalent exponential form of a square root is 1 over 2 as an exponent. Okay, minus 5. Again here, application of exponential laws. That is a positive exponent as a denominator. When you go in reverse, of course, it will be a negative exponent when you take it up. And then the constant function, it has no problem. We have plus half pi. Okay, write the stuff neatly. This is still y, x to the power of what? 3 times a half, application of exponential laws. Okay, a power raised to a power minus 5, x to the power minus 1 plus a half pi. Okay, now there's a power function, a constant function. So your function is ready to be differentiated. Okay, so now you bring in your notation dy over dx. You are ready to differentiate y with respect to x. How? Power rule will now apply. Okay, as you can see, it's a difference of functions, the sum of functions. So we're just applying those 2 rules at the same time. You drop your exponent, 3 over 2. The resulting, exponent will be 1 degree less than the original one. Minus, you drop your exponent, it's minus 1 times the coefficient there is 5x. The resulting exponent will be 1 less than the original exponent. And the derivative of a constant function will be 0. Okay, because a half pi, you see it as one number. Okay, it's half of pi basically. Okay, you write your stuff neatly. You have 3 over 2 x to the power of what? 3 over 2 minus 1, you get a half. And a double negative for you will produce a positive for you. 1 times 5 is just 5, and x to the power of minus 2. Okay, so if your question is clear in terms of how you must leave your answer, say in this case you are asked to leave your answer with positive exponents, you realize that I must deal with this guy. This one is fine, it's a positive half. So then you can go a step further and write it in this form, plus 5 over x to the power of 2. Okay, so guys, this takes care of sum and difference rules under differential calculus. Okay, differentiation of functions. I believe this was helpful, and thank you for tuning in. See you next time. Sharp, sharp.